Okay, so we've seen some indexing already. We're going to cover a few more. So the main one that we've seen is using this bracket notation, where you you write the name of the data frame and then the name of the column inside brackets, and it will give you that column. But there's a few other options. So first of all, let's just look at our data frame here. This is what we've got. Yours should look like this. So to just get a single column, you can just type the name of the data frame, square brackets, and then the name of the column in quotes. And if you want multiple columns, you can pass a list. So you need to have this second set of brackets, because that is the first set of brackets is saying, okay, here I'm going to pass a column or more, but if you want more than one column, you need to specify the columns as a list. Now, one really handy shortcut is if the name of the column is just alphanumerics and no spaces or special characters, you can just write df. Df dot the name of the column, and you'll get the same thing. So this is really handy, and this is one of the reasons why I recommend that you name your columns preferentially in lowercase and with underscores, and that's it. Maybe numbers, but you want to avoid those too. And it makes it really easy to type and to get the data you want in a really handy way. So there's a couple other ways to index, and these are more for rows. For columns, typically your columns will have names that are meaningful, and typically you can just use this dot notation or bracket notation. For rows, you can either index or get a row by its name or by its position. So if your rows have names that are meaningful, you can use the name of the row. So here we have, and we use this loc function. So we use df.loc or location, and we pass the name of the row in brackets, just like we do with columns. But now we have to add this .loc function. And again, we can get multiple rows passing a list of row names. So we named our rows A and D, and so we just use the .loc and then pass a list of those row names. Now, if we don't know the name of the row, or we want to just index by position, we can just use this iloc function, which is index location, and just pass the integer value. So this is giving us the same thing we had here. So we're getting, and by the way, when you index a single row, effectively that's a series. I think we saw this before. So a single row is like a series in pandas, right? It's a single list or array, or it's actually a series, and it has because it has mixed data types. When it's rendered like this, it's considered an object data type, because it's got floats and integers and strings in this case, so it's all kind of blurred together as an object data type. So yeah, so when we can basically, we're getting the same thing here, and it's telling us that the name of that row or that series is A, data type is object, and here are the values. And each of these values has its own index, which is the column names. So it's we're sort of slicing it. Instead of slicing by a column, we're slicing by a row. Again, we can get multiple rows by using a list of positional indexes. And the nice thing about using the positional index is it's really handy to do slices. In this case, we don't need to put this in brackets because it has a special meaning. We're getting from position 2 to the end. And I should point out that you can use positional indexing with columns. If you want to do that, you use this extra argument. So we're going to use a colon for all rows. So we're going to say all rows, comma, and then the positional indexes of the columns. So this would be column position 0 and column position 2. For me, I have to do some trial and error with the indexes. It's not always like immediately intuitive for me, and I forget like exactly which behavior I'm going to get. And in fact, there used to be a third indexing function called IX, which could handle both positional and label-based indexes, but they did away with that in the newer version, I guess because it was redundant, or it had I think it also had unintended behavior depending on how you used it. So this is sort of a simpler way now, but there's a lot of flexibility in how you can index and slice a data frame to get what you want. So just a little review here of the transpose function. So again, we have two ways to transpose a data frame. So here we're looking at our teams, and so we've now turned the columns into rows and the rows into columns. And the same thing here, we can use .t like in MATLAB to get the transposed data frame. But these are not done in place. So if we want to save, if we want to make this change permanent, we have to do something like df equals df.t. I'm not going to execute that because I want to do something with this data frame. But yeah, if you want to make the change in place, you need to do something like that. Okay, and then we saw read CSV before. We're gonna see to CSV. So this is how you would save a file. So a little syntax review here. So when you're reading a file, you're using, in both cases, you're using pandas functions, but in the read CSV file, the function is a function within pandas. So it's pd.readcsv and then the name of the file that you're reading, and then it returns a data frame. To write a data frame, you already have this data frame object. So we have this df data frame object that has its own methods. And one of those methods is to CSV. So this is an attribute or a function of a data frame. So a data frame can be written to a file. So this function is called to CSV, and it also supports other. We also have other options to tab delimited or Excel, but this one is to CSV, and so you write the name of the file, and it will just write that to a CSV. So we can enter that function, and then we can go back to our. If you opened up a second terminal window, you can see that we just created this new file, teams.csv. So if we just want to view that file, we know it's a small file, so we can just type cat. And you can see that we've created this CSV file now in our home directory, or in our working directory. So this is we have our header column here, which has an empty, sort of the first position is empty, and then we have the names of the columns, and then we have the indexes, and then the data. So this is a comma separated values file. If we wanted a tab separated values file, we can use the same function. It's a little confusing, but to CSV, but it's not gonna be CSV exactly. It's gonna be TSV, or tab separated values. And all we have to do is specify this argument sep equals tab, and tab is noted with a \t. And when we did it with CSV, that comma was implied, so sep equals comma, so that we could have done this, but that's redundant because that's the default setting. So if we want to make a TSV file instead of a CSV, we can use the same function, but we just specify the separator. Now if we go back to our terminal, we can see we've now created a TSV file. And you can see that it's now, those commas have been replaced with tabs. And if you want, you can open this file with Excel, and it should, you might have to do some importing, but it can, just like any CSV or TSV file, you can open it with Excel. But there's also a toExcel function. And this might generate an error. So let's work through this. So it says no module named OpenPyXL. Okay, so what that means is that we don't have the module we need. So this does not come automatically with Pandas. We have to install this package. So does anybody remember how we install a package? Go to the terminal. Yep. Okay. So we can go to the terminal. We can go back to the terminal here. What do we have to do though before we install the package? Right. Because so one of the things about Jupyter Notebooks is it creates this. It kind of takes over your terminal while it's running. We can go, yes, so it's two ways. We can go to the terminal in the notebook. We've done that before. We can also go to the terminal on our desktop. We just have to activate that. We just have to activate that environment. So we source activate Python 3. You'll see the little Python 3 down here. So now we're in the environment. So anything we install now will be installed in that environment. And so what do we need to type to install that package? Right. Conda install, name of the package, which is OpenPyXL, is that right? Yeah. OpenPyXL. So do that, hit enter. Now while that's going, if you want to install a package, I recommend you do it this way first. You make sure you're in your environment, make sure your environment's activated, and then type conda install, the name of the package. If you get a message that says package not found, then your second option is to do a pip install. Pip is another Python package manager, and pip works with conda. So if you're in an environment and you pip install something, it will get installed into your conda environment. But this one is found. It said, it's solving this package specifications, and so it's saying we need to install these 3 packages. So basically, OpenPyXL has these other 2 dependencies. So we'll say yes, Y. And now we're going to go back to our. Now this one's interesting because we don't have to import this package because it's used by Pandas automatically, so it should just work. Yeah. So we went back to our notebook now and we executed this toExcel. And now we can go to our lessons folder look at the most recent files, we see we now have this teams.xls. So if you have Excel on your computer and you're using a Mac, you should just be able to type open teams.xlsx, and where'd it go? There we go. And this is what it looks like. So we've just created an Excel file from our data frame, and it maintains the full values of the random numbers, and it's really handy. So this is a way you can write to an Excel format. You can also read Excel, which we'll see in a minute. So and I'll update the notebook based on the changes from today.
Look,
Yeah.
you write into